Hello, everybody. First, I will talk about a mathematical model for controlling of thin film composite layer on the porous blended membrane. Outlines, I will discuss about introduction in the work, model development, model validation, and conclusion. As we know, there are 4 types of membrane for water treatment. Microfiltration, ultrafiltration, nanofiltration, and RO, and these are different from pore size, as the microfiltration is the pore size is large than 0.1 micrometer. For ultrafiltration, take a range from 0.1 to 0.05 micrometer. And nanofiltration from 0.005 to 0.001 micrometer, and last one, reverse osmosis, less than 0.001 micrometer. These membranes can allow some particles, as we know, and prevent the other particles to pass. We have 2 steps for membrane fabrication. For manufacture of substrates, we use phase inversion technique. For polyamide layer, we use interfacial polymerization. So what is the meaning of phase inversion? It's a demixing of polymers with a solvent to convert a polymer solution to a solid or to make a substrate. So we have 4 techniques for phase inversion: immersion, precipitation, as we see in this picture. This technique is by mixing polymer solution and spread it on a flat sheet or on a plate, then immerse the plate in non-solvent or in water to make a substrate, and then it driven by atmosphere. Thermal induced phase separation by lowering temperature, evaporation induced separate by evaporate a solution of solvent and non-solvent to evaporate a volatile solvent solution. First technique is a vapor, in which placing cast film in a vapor phase contain a non-solvent solution. So the most common technique is immersion precipitation for make a substrate. For make interfacial polymerization, interfacial polymerization is the most important technique in a commercial fabrication of thin film composite layer. Mostly take place in a reverse osmosis or in a nanofiltration membrane, and the commonly polymer used is metaphenylene diamine with trimethyl chloride, and also we can use a polymer vibrazine with isophysiloid chloride and hexane, vibrazine with trimethyl chloride and hexane, 1,2-ethane ethane diamine with disulfonide chloride and chloroform, and carbon tetrachloride. This picture is illustrate how the interfacial polymerization takes place, as we have 2 monomers, monomer A in a reaction zone or in support membrane, monomer B in organic zone, and monomer A will diffuse to the surface of the membrane and take a reaction in the reaction zone sigma between the monomer A and monomer B in organic solution. So the polyamide layer will form in the interface of the membrane. Aim of the work: to development and verification the mathematical model for thin film growth layer membrane by interfacial polymerization, by verification of the model development by using Lapa scale, modification and development of the fabricated ultrafiltration by polyether sulfate, and polyacrylonitrile blended membrane in which polyamide selective layer is introduced on the borders of the blended membrane by using piprazine and alpha-phthalate chloride. Last, by using MATLAB code or software for solving second-order partial differential equation. Model development. A general model has been investigated for synthesis of thin film composite flat sheet membrane by diffusion and reaction-controlled interfacial polymerization. First, we make some assumptions before make a model, as we put as the system is considered in the interfacial polymerization of monomer A and in aqueous support, in aqueous solution and support membrane, and monomer B in the organic phase. The newly formed polymer doesn't dissolve in either organic or in aqueous phase, and the density of the thin film is uniform during the reaction. Last assumption is the reaction will take place at sigma at the reaction zone, as we said before in this picture. So for solving the relationship between polymerization time and thin film thickness of the interfacial polymerization, we use this equation. This equation developed in which X is the thickness of the thin film, phi p is the volume fraction of the thin film, and also can be calculated by the equation below. Mu is the average molecular weight, rho W is the density of the water, P is the density of the polymer, and beta is the molar ratio of the water to monomer A transported together by diffusion. Ki is the constant and also can be calculated by the equation the right. Kr is the second order reaction rate. Sigma is the reaction zone. Mu, as we said, is the molar molecular weight, or molar mass, and rho p is the density of the polymer. Finally, we put these equations in the main equation of the X. And C node is the initial concentration of monomer A, Cp is the concentration of monomer B, and C is the polymerization time. And from this equation, we get the relationship between polymerization time and the thickness of the thin film. To calculate also the relationship between polymerization time and growth rate, we can use this equation, in which R is the present growth rate of the thin film. A node, B node, C node, D node, and E node are constants and also can be calculated by this equation, in which Dm is the effective diffusion coefficient, Ki is the constant, Cp is the concentration of monomer B, C node is the initial concentration of monomer A, Fl is the fraction of A that diffuses out the top of the support membrane and take a range from 0 to 1. K is the partition coefficient of monomer A between the support and the thin film phases. Also, the other parameters or the other terms are we discussed before. So we substitute these constants in the main equation to get a relationship between R and time, the polymerization time and the growth rate. Last equation to calculate the monomer concentration. All of these terms also we discussed before. By using the first equation of thin film composite, we can make a comparison between different polymerization. So we calculate the thin film thickness of the polymerization time and the polymerization time for biprazine with isophenylate chloride, M-phenylene diamine with trimethyl chloride, biprazine with trimethyl chloride, 1,2-ethane diamine with trimethyl chloride. We found that the thickness of the thin film of M-phenylene diamine with trimethyl chloride, which present curve B, increase with time, and the thickness will reach 0.2 after 1.5 seconds. For curve D, which presents 1,2-ethane diamine, will reach to 0.2 micrometer after 1.9 seconds. 0.2 micrometer is the ideal thickness of the film, the good layer. With increasing time, we found that curve B and curve D will decrease rapidly. And while curve A and C, which present biprazine with isophenylate chloride and biprazine with trimethyl chloride, continue to increase with time. And biprazine with trimethyl chloride, curve C, will reach thickness 0.2 micrometer after 10 minutes. Curve C will reach 0.2 after 4 minutes, and while the biprazine with isophenylate chloride, curve A, will reach 0.2 after 10 minutes. So, biprazine and trimethyl chloride, biprazine and isophenylate chloride will take a long time to form a good layer. Model validation, we set an experimental to prepare interfacial polymerization and polymeric membrane by using 0.1 weight percent isophenylate chloride and 2 weight percent biprazine in normal hexane, and prepare polymeric membrane by using 14 weight percent polyether sulfur with 4 weight percent polyethylene glycol and 1 weight percent polyacrylonitrile, which dissolve in 1-methyl-2-pyridine and annealed at 5 minutes for 5 minutes and at 80 degrees Celsius, and soaking the membrane for a different time, 10 minutes, 15 minutes, and 20 minutes. The results we see for membrane soaking time 10 minutes, the thickness will be 0.168 micrometer. For 15, the thickness will be 1.99 micrometer. For 20 minutes, the thickness will be 0.295 micrometer, which is which increasing the time, the thickness will increase, as we said in the membrane morphology. By putting the actual results in a theoretical model, which we calculate, we found that there is a small deviation between the theoretical model and the actual results. So, conclusion, we conclude that under non-steady state condition, the theoretical model predicting both diffusion and reaction controlled interfacial polymerization thin film composite membrane has been created, the mathematically applicable to any types of interfacial polymerization. In the early stage of the polymerization, the thickness of the thin film produced by interfacial polymerization rapidly increased, then leaves off. The model has been validated using actual data, and the results show good agreement with the real data. Thank you.
Time factor as a test factor. How to stop the action? Sorry, how to control the action after 10 minutes, 15 minutes, 20 minutes. You see.
موعد هو يعني بنقيس التايم بنقيس يعني مش بوقف الرياكشن، فانا بعد تايم معين بحسب هو الثيكنس وصل قد ايه. بعد كده يعني ده الاكتوال نفس الكلام. الكيرف اوريدي هو بيرسم ريليشن بين تايم يعني حضرتك بتسال على الاكتوال بيحصل صح؟ هي الفكره انه افتر تايم معين انا بوقف التايم بحسب رياكشن حصل دلوقتي الثيكنس ظهر قد ايه، مش بكنترول فيه واقول ان التايم الرياكشن وقف.
ارجعي دكتورة، ارجعي دكتورة.
اوكي شكرا.